Hello! This video is going to give you a basic introduction to how to use SpectrumView to analyze musical notes. So first of all, there are essentially two different ways that you can display data using SpectrumView for our purposes. The first is in frequency mode, you'll see here. Now when you first start, you'll just want to hit start to get something rolling, and now you will see that there's a spectrum of frequencies popping up that's based off of the way that I'm talking right now. And if I wanted to instead play a musical instrument, say this penny whistle, you can see the spectrum pop up. Notice that on the x-axis is frequency, and on the y-axis right now is sort of an amplitude that is based off of decibels. A couple of things that you'll want to make sure that your display is in. The first, the vertical display is probably easiest to be displayed in log scale. You'll see this looks like it's kind of a decibel scale. In the horizontal direction, you'll want to be in linear scale. This will allow us to see these harmonics a little bit easier.
So one of the things you can do with SpectrumView is pause a particular moment in time. So right now it's just on start. You can see it's floating and various things are happening. Now if I go ahead and play a note, you can see by pushing single here, I've stopped it. I could also push stop. This allows me to go through and actually see what the frequency is at various points. So if you notice, I have this little crosshair cursor. If I put the cursor here, it's going to tell me up in this corner right here what the frequency is and what the amplitude is. One thing to note is that this cursor works such that if I click somewhere, it's going to zero the place that I clicked. So now if I move this way, I end up having negative frequency, and if I move this way, I end up having positive frequency. I suggest avoiding doing the click and just maybe starting with a click over, make sure that you've got it zeroed. So now I'm back here is my 0, and if I move forward I get the frequency that I'm at. So you can use this to pinpoint exactly where peaks are at in terms of frequency and amplitude. Two things that you will want to play with are the sample rate and transform size. We suggest using the 11,025 as your sample rate and 4,096 as the transform size. The sample rate is dealing with the number of samples it takes per second, and it determines the range and frequency you are going to see. So whatever your sample rate is, you basically cut that in half, and that will be the range of frequencies from 0 to whatever it is. So here is 11,025. And our resulting end of the frequency range is 5,512. The transform size is going to basically end up putting the information into little bins. It's telling you how many bins I'm going to break this up into. If you have a large number of bins, you're going to have a lot of specific detail in your spectrum, but the number of times that it updates will be slower, versus if you have a low transform size, you won't have as much detail, but it will be updating at a faster rate. This is 4,096 is our suggestion for that. You may end up having an experiment where you are very interested in watching the time sequence of your frequency display. So this is where you can change from display, go up to display, and change from frequency to what's called waterfall. Now what you'll see is that you end up getting this time sequence that starts up at the top and it scrolls down. Right now it just kind of looks like a bunch of crazy dots on the screen, but if I go ahead and start playing our instrument here, the penny whistle, you can see now that we've got these peaks that show up as sort of white areas. Those are the the natural frequencies of this penny whistle. And then as I change my fingering positions, I can see the new spectra that is created. So you might be able to use this if you want to be able to compare directly to different situations and be able to play one and then compare it to the other. It's really going to be up to you to decide which makes more sense for your given situation. At some point, you are going to want to save a picture of your data. So you go over to File. There are a couple of options. One is that you can save it as a view file, which would then save it within SpectrumView. And if you were to open it up again, it would open up SpectrumView, and you would be able to do analysis on it just like you would do analysis on it with it stopped here. If you wanted to just save the picture, the image, you can use Save Form, Save Graphic, or Save Bitmap. Save Form is going to capture the entire screen, including your toggles around the edges. Save Graphic is going to just take this bit here and will include your peak frequency, your scale down on the bottom in terms of frequency, etc. If you select Bitmap, you will get information, only the data without any of the words on the outside of the graph. So one final thing I would like to share with you is that you can import WAV files, WAV files, into SpectrumView and analyze them. So if you wanted to, instead of trying to use this and make your sound every time in this program, you could actually use a sound recording program, record a WAV file, and then input it into SpectrumView. So I have a WAV file that I'm going to use. I'm going to go ahead and go to File, Open WAV File. And then I have the sound test WAV file that I'm going to open. And now as soon as I hit start, you're going to see that now what is showing up right now is not the noise that I'm making or the frequencies that I'm making, but actually something that I'd recorded earlier. You can't hear the sound playing back, so it's a little unclear what is going on at this given time, but you can do this in both frequency mode and waterfall mode. That's it for now. Good luck, and let me know if you have any questions.